Hello again, everyone. I'm Steve Marsh, an instructor at Clarkson University and a certified Lean Six Sigma Black Belt. In the previous module on hypothesis and significance testing, we heard Professor Hoover discuss the scientific method and principles used to acquire knowledge from observations for decision making. In this segment, I will introduce the DMAIC model, a similar data-driven approach used to reduce process variation as part of the Six Sigma methodology. By the end of this module, you will be able to define Six Sigma, explain the DMAIC model, understand the theoretical basis for Six Sigma, measure the impact of Six Sigma on process output, and describe the organizational benefits of Six Sigma. The term Six Sigma can mean many things to organizations that follow its principles. First, Six Sigma represents a philosophy that can be applied to reduce process variation by defining all work as a series of processes and controlling the output by controlling the input variables. Six Sigma incorporates a set of qualitative and quantitative tools applied in a five-phase approach known as DMAIC. This will be further defined later in this module. Six Sigma level performance implies that variation has been sufficiently reduced such that if we allow a process to operate for 1 million cycles and analyze the results, we would expect no more than 3.4 defects to occur, allowing for the impact of random background variation inherent in all processes. Adhering to the discipline of Six Sigma can bring many benefits to an organization, and we will discuss these in greater detail here. Six Sigma encourages the use of teams that are assigned well-defined projects having direct impact on the organization's bottom line. It provides training in statistical thinking at all levels and enables key people with extensive training in advanced statistics and project management known as black belts. It places emphasis on the DMAIC approach to problem solving, including the define, measure, analyze, improve, and control phases. It creates a management environment that supports these initiatives as a business strategy. And finally, Six Sigma promotes continual effort to reduce variation in all processes within the organization. In addition to the financial and performance benefits just discussed, following the Six Sigma methodology also brings a hierarchy of leadership and technical expertise to an organization. Let's examine the levels or belts typically associated with Six Sigma practitioners. We'll start at the process level and work our way up. Project team members, often called yellow or white belts, contribute to projects, participate in data collection, and process studies. Green belts support projects, identify issues and barriers, and facilitate teams. A black belt leads projects, applies graphical and statistical tools, and calculates savings in the form of return on investment. A master black belt coaches and mentors black belts, providing training and selecting projects. Process owners select team members, approve and sustain process changes. A champion serves as a liaison with senior management, removes barriers, and helps implement change. An executive sponsor establishes direction, priorities, vision, resources, and rewards. Now let's discuss the five phases used to implement Six Sigma on a target process. During the define phase, we identify the issue causing decreased customer satisfaction. In the measure phase, data is collected from the process. During the analyze phase, we study the process and data to understand what is going on and identify the root cause of the problem or defect. In the improve phase, we act on the data to change the process for improved performance. Finally, during the control phase, we monitor the system to sustain the gains. Across the DMAIC phases, there are specific tools and activities applied at each stage. Tools used in the define phase, such as the SIPOC diagram and flowchart, are used to understand the current operating state of the process. In the measure phase, a data collection plan is identified and measurement system analysis is performed to ensure the data source is reliable. Hypothesis testing and graphical analysis are conducted in the analyze phase to identify key process variables. Designed experiments and failure modes and effects analysis are conducted in the improve phase to prioritize a list of potential solutions and evaluate risk. Finally, control plans and SPC are applied in the control phase to ensure implemented solutions are effective and sustainable. Note that the one element common to each phase is management commitment, which is essential to successfully implement and sustain a Six Sigma culture. Following the five-phase DMAIC approach provides a roadmap that organizational leaders and process owners can follow to lead to improved performance. We start by recognizing that variation exists in everything we do, and that helps us to standardize our work. Next, we identify what the customer wants and needs and begin to reduce variation. We use a problem-solving methodology to plan improvements, follow the DMAIC model to deploy the improvement, monitor the process using process behavior charts, update standard operating procedures and identify lessons learned. Then it's time to celebrate successes and then start over again for continual improvement. The Six Sigma philosophy states that the output of a process, represented by Y, can be controlled by understanding and controlling the process inputs, represented by X. In this way, it follows that Y is a function of X. Let's consider an example of a restaurant owner with a goal of improving customer satisfaction. Through customer surveys and feedback, the owner learns that food quality, the level of service, and the restaurant's ambiance are essential in ensuring customer satisfaction. By brainstorming with staff and benchmarking other restaurants, the owner learns that food quality is impacted by quality ingredients and good recipes. Service is improved with prompt attention and a professional waitstaff, and ambiance is enhanced through pleasing decor and appropriate music. Establishing cause and effect relationships and focusing on the correct input variables should positively impact the output variable, in this case, customer satisfaction. A process operating at a Six Sigma performance level means the distribution of process output, represented by the familiar bell-shaped curve, is operating well within customer-designated upper and lower specification limits. Further, variation is so tightly controlled that there are 3 standard deviations, or 3 sigma, between the lower spec limit and the lower tail of the distribution, and another 3 sigma between the upper spec limit and the upper tail of the distribution, for a total of 6 sigma. This signifies a substantial margin for error, which allows the process mean to drift due to the effects of common cause variation, with a very small probability of producing output beyond the specification limits. In other words, 3.4 defects per million opportunities. As discussed earlier, a common metric for Six Sigma is defects per million opportunities, or DPMO, which decreases as the sigma level increases. For example, a process operating at a 4 sigma level would be expected to produce 6,200 DPMO, while a Six Sigma process results in 3.4 defects per million opportunities. DPMO is calculated by multiplying the number of samples by the opportunities per sample, dividing this value into the number of defects observed, and multiplying by 1 million. Let's work through an example to further illustrate how DPMO is determined. Suppose that an airline wishes to measure the effectiveness of its baggage handling system. It might measure nonconformances per unit by calculating the number of lost bags per customer. However, customers may have different numbers of bags, thus the number of opportunities for error differs with each customer. Suppose that the average number of bags per customer is 1.6, and the airline recorded 3 lost bags for 8,000 passengers in 1 month. Then, using the formula, we have 3 lost bags divided by the quantity 8,000 passengers times 1.6 bags per customer times 1 million, equaling a DPMO rate of a little over 234. This is equivalent to a process operating at a 5 sigma level. Management must now decide if the cost to improve to a 6 sigma level performance is justified by ticket price and overall customer satisfaction. This concludes our discussion of Six Sigma and the DMAIC method. As you progress through the remainder of the Manufacturing Statistics microcredential, keep in mind that Six Sigma incorporates several statistical tools to measure, analyze, and improve manufacturing operations. Thanks for following along, and I'll talk to you again soon.